And now we're going to talk about more fun things with fractions or polynomial fractions. And the next thing is to multiply them. Oh, Young, this is getting so fun. To multiply rational expressions. Now notice I wrote factor if necessary, and simplify by canceling or chopping all common factors or opposites. So you can go, yeah, and to divide rational expressions, multiply by the reciprocal of the divisor, just like you would with regular numbers, and then factor and simplify the result. So let's go to a few cases of those here. We're just moving right along here today on the old BCC network. And notice we've got some more factoring things we can do. We're going to multiply these fractions together, but first we can take the difference of squares, which we saw in an earlier example, factors into x plus 3 times x minus 3, the conjugates, if you remember what they're called. All right, this can't factor, he's just by himself here. So let's go to the second fraction. How can I factor this binomial in the top or numerator here? Well, something in common. You can take an x out, and that will leave you with x times x minus 3. And in the bottom, to factor this trinomial, the outside numbers multiply to give us 12. Factors of 12 that will add to give us 1 would be a plus 4 minus 3. Would be those rainbow numbers. And notice the examples here, there's a lot of 1s in front of the x squared. That's nice. So when we factor this one, we end up with xx plus 4 minus 3. So remember when you were multiplying fractions in grade school, you could reduce up and down if you had a common number or factor, or you could diagonally cross-cancel anything in common. So as these get larger, even with polynomials, they work the same. So let's go to some neat colors here, and let's chop what we have in common. So I notice I have an x minus 3 on both top and bottom here. Reduces to 1. All right. What else reduces? Some of you are saying, well, I don't see anything else that reduces, Young, but there is an x here to the first power and an x squared. You can chop an x out of the top and an x out of the bottom, and where does the x end up? Down here. And we'll put it in pretty blue, x. Yeah, so I don't see anything else in common to factor now, so let's go ahead and write that answer. So we multiplied these two rational expressions together, and what's left is x plus 3 times x minus 3 in the top, all over the x in the bottom, times the x plus 4, and that would be the reduced answer as well, because there's no common things to cancel or chop here. Don't try to chop anything there. Okay. Next example, same thing. We're going to factor this first fraction's numerator by taking a common factor of 5 out, and that leaves us with 5 times y plus 1 over, this is already factored, can't do anything with that binomial. Over here, this is one of our friends, the old trinomial square. It's a baby one, but it is. That's one when we factor, we'll get 2 of the same things. In this case, we're going to get y. Both signs have to be the same. Both have to multiply to give me a positive last term and add to give me a negative middle, so they'll both have to be minus minus 2, 2. All right. And notice I've got the old difference of squares in reverse down here, and when I factor this, I get 1, 1 plus minus y. All right, so let's go ahead and cancel now. So some of you, once you factored, you can now have some fun and just take out these common factors and get out the black belt here. So when we factor now, we have a y plus 1 in the top and a 1 plus y in the bottom that reduces to what? Positive 1. All right. Just because it's the same thing, so be careful there. They tried to use the commutative property on you and fool you. Don't let them. And then over here we have a y minus 2 in the bottom. We can cancel with one of the y minus 2's in the top and put same thing. Cancels or reduces to 1. And is there anything else we can cancel or reduce in the problem in the top or bottom? I see nothing else, so we'll go ahead and write that answer then of 5 times y minus 2 over what's left in the bottom is 1 minus y. And you don't really have to even distribute the 5 through. You can and get the answer. And up here, some of you might have said, well, do you FOIL this back and get x squared minus 9 and distribute that? No, they usually, once they factor everything and reduce these polynomial fractions, these rational multiplication expressions here, they just leave the answer in that form, in the factored form. So that's kind of nice. All right, and let's take a dividing example real quick. Now remember, even when you guys were doing in grade school dividing fractions, there was a rule, and that's that definition of division we talked about in earlier episodes. You can't divide fractions, so you must take and multiply by the reciprocal of the second fraction. Okay, so that's the definition of division. Division can be rewritten as multiplication by taking and multiplying by the reciprocal. Even works with polynomials just like numbers. All right, so when we factor this, again, the difference of squares, boy, those things pop up a lot. And when you guys do a lot of problems in your textbooks, you'll find that. You'll see those difference of squares popping up all over the place. So those should be no problems popping the conjugates. You can take that common factor of 4 out of the bottom here. And that'll leave you with an x plus 3, and then you can go ahead and get the scissors out or get the chop out and do your action on it now. So what are we going to chop? I see an x plus 3 in top and bottom that cancels to 1. An x minus 3, diagonal here, cancels to 1. And is that all? No, we can also cancel. This is not a full chop, I call it, but a partial chop on the 4 and 6. We can take a 2 into the 4 and a 2 into the 6 and reduce it that way as well. See, so we could have written 6 as 2 times 3, 4 as 2 times 2, and cancel that common 2 out, leaving us with these numbers in nice green here. So what's left is a numerical answer. We started with multiplying all of these polynomials, and it reduced to the answer of 3/2. What do you think about that? Yeah. And now let's take one of the worst ones. You know, on the BCC network, we always tell students we just don't do the easy problems. We take the tough ones and knock them out as well. We just don't back down from them. So on this first one, I'm going to go ahead and factor this one out here. And well, maybe I better go ahead and rewrite this because we know we can't even write division. So if I saw a problem like this in a textbook and I was practicing, multiplying and dividing these rational expressions, I wouldn't even write the answer like that. I would go ahead real quick here. And when I copied it down, when I practiced, I would go ahead and leave that first fraction alone and multiply by the reciprocal of that second one. Okay, so this is a load to flip right here, isn't it? Okay. Hope I have enough paper here. So when we keep going now, we can take a common 5 out of this first fraction's top, leaving us with x squared plus x minus 6. A common what in this binomial here? We could take a 10 out. So all kinds of good things happen in here. And that'll give us x plus 3. A common what out of here? You can take a 6 out. So this is about the worst case scenario on one of these. And you get x squared plus 6x plus 9 all over a common what here? 2, which gives us x squared minus 4. So now we can still continue to factor these trinomials here, and I think we've got the difference of squares going here, so things to recognize. So we'll go ahead and keep on a trucking here. So this x squared plus x minus 6, factors of 6 that will add to give me 1 would be xx plus 3 minus 2. So these will add to give me 1 in the middle and multiply to give me the negative 6. All right, this bottom one we've got taken care of, and that's going to stay 10 times x plus 3. Can't do anything else with it. Over here, do you recognize what kind of trinomial is? Anyone out there? It's a trinomial square. First and last terms are perfect squares. So when we factor that, we're going to get x plus 3 not once, but twice. So remember, when both of those signs are plus, both of these will be pluses. We had one earlier where that was a minus in here and both signs were negatives, or minuses. And on the bottom, there's that difference of squares again. It doesn't go away. 2x plus 2 times x minus 2. So the factoring the difference of squares gives us our conjugates. Boy, now you've got a chop smorgasbord here. I mean, look at this. This is a smorgasbord. I mean, you might be going crazy on this chopping, so let's go ahead and do it with a different color here. We like to hit you with colors. Now notice on the x plus 3s, you have some choices. Do you want to cross-cancel them over here, or you want to cross-cancel this one and this one over here? Doesn't matter. It does not matter at all. So I'll go ahead and just take these two, since they're closest together here, and they reduce to 1. What else reduces here? Well, I see an x minus 2 in the numerator and an x minus 2 in the denominator. So we'll go ahead and chop those. Same thing, 1. Okay, what else? Now we've got some numbers that also reduce, don't they? 5 goes into 10. We can cancel a 5 out. 5/10 reduces to a half. And then we've got 2 over 6. 6 halves reduces to 3 over 1. So when you cancel, be careful here. 2 goes into 2 once and goes into 6 3 times. So make sure you end up with your numbers in the right spot. And is there anything else once we cancel all of this down here that reduces? I don't see anything else in common here. So I guess we'll go ahead and write the final answer when the smoke clears, and I'll bring it up here to the top. Notice how I sneak this in on my paper here. So the final answer would be x plus 3. There's 2 of them left, so we'll write that sophisticatedly. X plus 3 quantity squared. We're getting sophisticated in our approach now. All over. What's left on the bottom? The 2 here. And, oh, you know, I forgot something in the top here. There's that 3. Don't forget the 3 up here. So the 3's up there, too. I almost forgot that. Ooh, that's the danger of doing one of these large ones here is you have to be sure you don't miss anything when you go ahead and write the answer. And then on the bottom, you get the 2 times the x plus 2. We're going to have to get some bigger paper here on the set for the film guys here. Look at this, as these problems get larger. I think I'm starting to scare them back there in the back. They're going, no, young, but they're all right. Yeah, all right. So let's talk about something else here now. Let me go to the camera here. Next thing we're going to talk about now, we have talked about polynomial fractions, which are rational expressions. We have talked about reducing them to 1, -1. We've talked about multiplying them by factoring and reducing them to 1 or -1 and putting what's left. And we talked about dividing rational expressions now by multiplying by the reciprocal, I'll spit it out, and factoring and going ahead and putting what's left. So what's left with fractions that we haven't done yet? Well, we've reduced them, we've multiplied them, we've divided them. Oh.